Jake Martin, Hydrogen Business Development Manager in Haskel, is going to talk to us about hydrogen refueling stations. And I think it's becoming increasingly apparent that today we're not talking about hypothetical projects we'd like to see realized in some point in the mysterious future, but about real projects that are happening right now as we speak. Jake.
Great, thanks very much. Two things before I get started. I'm a very vibrant speaker, so I know everyone's asleep. So first of all, congratulations for making it this far today. Pat yourselves on the back. Second of all, I must apologise because I am British, and I have noticed the slight dig in the fact that you've taken down my flag. You know, she only died last week, guys. Come on. A bit of fun. So I'm Jake. I'm the Hydrogen Business Development Manager for Haskel, wholly owned by Ingersoll Rand. And really, we've been speaking a lot today about how hydrogen is a thought, how hydrogen is the future. But really, we need to talk about what's happening now. You know, we've been in this market for probably the last 10 years. So my challenge to you in this next 15 minutes, I've got my timer on, so don't worry, is to make me more interesting than your Instagram story or your emails, okay? So first of all, one thing I'm going to ask, I'm very interactive, is there's a number on the board. What's people's first thoughts of the opinion of the number? Anybody got an opinion on that number? Anybody? It's massive, it is. How many zeros go after 10? Come on. 19 zeros, it's a big number, and I'm going to come to that at the end, okay? And it's really important because we're going to be talking about standardization and why the market is absolutely desperate for standardization, okay? So get your phones out. Anybody who's in sales and wants to show to their management the numbers, this is a really compelling chart of numbers, okay? So key takeaways from this. There's a massive delta in stations planned. So from 2021, 2022 now obviously, to 2028, there's a massive increase. It's 33.97% increase, okay, over 8 years. So this is pretty compelling because you can see, let's just use Europe as an example, 338 stations, and by 2028 we're looking at 1,846. If you're going to put your money somewhere, I would be putting it on those statistics. If you then look at that from a cash perspective, okay, so again, combined aggregate over 8 years, an increase again of 33%, but you can see the numbers, okay, so Europe, 220 million, right up to 1.1 billion, okay. Again, if you're going to put your money somewhere, I would be definitely putting it in hydrogen. So Haskel, who are we, what do? We don't just do compression and pumps, we supply hydrogen refueling stations and applications, okay? So if you're looking at using a hydrogen refueling station, it will have 3 sections of that refueling station, and I'll talk about that in a second. We've got over 200 references worldwide. Probably the most exciting is the Beijing Olympics. We supplied 3 refueling stations for that, 120 buses over 24 hours, back-to-back refueling, 10 to 15 minutes. Okay, most exciting thing for us, and the reason why we're here today, is we're supplying you a station in Slovenia. You've already got one of ours in Slovenia right now, and we're looking at moving that into an additional one very, very soon. So it's exciting to really be stepping into this market. So standard sales pitch about Haskel. We're owned by Ingersoll Rand. Ingersoll Rand is that massive company that owns everything from golf carts to pumps. Okay, so why not? Let's buy a hydrogen refueling station company. Really quite clever acquisition actually, because the heart of refueling is compression. If you don't have compression, you don't have a station. It's that simple. So Ingersoll Rand, Gardner, Denver, they merged, and then we've got our 4 facilities all around the world. We've got California, which is our authority for compression, it's our design authority, and then the UK and France, where we manufacture our stations. We've just emigrated a whole team across to Australia, supporting the effort there too. So that's a really quite an exciting market for us. So again, we cover the whole project cycle, so initially designing the stations right down to manufacturing and testing. The only reason I put this up is not to say, look at what we do compared to everybody else. It's because the testing section is really, really important. So the 200 stations we've supplied, every single one will go through a FAT on site with hydrogen, okay? So we're using that hydrogen through the system as if it's a full refueling station at site. So before it even gets to the customer, it will be fully functional before it leaves site. A little bit different to what a lot of other people do, where they use nitrogen. So standard stock images for hydrogen stations. I'm going to cover 1 or 2 of our flagship stations. We're working very closely with a company in Belgium called Colruyt. Colruyt are owned by Walmart, and they're moving their logistics fleet into hydrogen, so shifting all that food produce around using hydrogen. And then another really exciting one is the marine. So over in New Zealand, we're supporting the hydrogen chase boat that is part of the Emirates Sailing Cup. So if anybody's into sailing, you'll see the boats are flying around on their big hydrofoils, and just in the background there's a few boats following them. They're now going to be hydrogen, and it's by a company called Haringa. So we're supporting them now. So amongst many other different projects, buses, trucks, cars, trains, they're two of the sort of really exciting ones. So everyone keeps talking about hydrogen refueling, but why is it interesting? You know, it's safe, it's efficient, it's odor-free. Somebody in the room give me some issues with hydrogen. Why is it a problem? Explosive? Anything else? We'll stick with explosive, the worst one. Okay, so hydrogen naturally is a very volatile molecule, but the best bit about it is it's gas. It disappears when you let it out of a location. Everybody in this room has been sitting on a tank of liquid petrol or diesel for the last 100 years, okay? So it's fine, don't worry about it. The system's designed to allow the gas to release in less than 3 seconds, okay? So the systems are very safe and effective. Rapid refueling, so you can get like-for-like refueling from petrol and diesel in hydrogen. So that's low pressure and high pressure, so 350 bar and 700 bar. And also, again, it's back to that speed, so you get like-for-like speed fill on your vehicles. So basic fundamentals of a station, and by no means this is not a sales pitch. I like to educate people actually on hydrogen stations and what to consider. So if you are thinking about getting a station, please take a picture of this. You can come to us and buy the lot, or you can go to everyone else and try and do it yourself, and then we'll fix it when you do it wrong. Sorry, that was a tongue-in-cheek comment. So yeah, essentially you've got 3 different systems. You've got storage, you've got compression, and you've got dispensing, okay? What we do is we take the molecule from wherever it comes from, okay? So if it's grid, it could be electrolysis, it could be tube trailer, it could be magic. However, you get that gas to us as long as we get it at 30 bar. It's a very simple system, so for the mechanical engineers in the room, we do a ratio of 6:1 on compression. So we take the gas at, say, 30 bar, we then kick it out at 180, do a second stage of compression, and take it right up to 1,000 bar. Okay, why do we need to go to 1,000 bar? 1,000 bar is perfect for a cascade fill. Again, cascade fill is not new engineering. This is very simple, basic fundamentals of engineering. And what we're doing here is what everybody says they're doing in the hydrogen refueling market. We're not doing anything cutting edge, okay? The market is getting lots of components and pushing them together to create refueling stations. What we're starting to do is standardize that. I'm going to touch on that in a sec. So once we've got that gas boosted up to a high pressure, we then hold it at 1,000 bar and 550, and then all we do is simply cascade fill the vehicles as they come along. Simple considerations around T0, T20 and T40, which I'll touch on shortly, but some really important fundamentals there, okay? So we take the gas, we boost it, we store it, we fill, yeah? Pretty simple. If we're talking about cascades, for anyone who doesn't know what that is, if you have one big balloon here, and then you have a fully deflated balloon, you tie them together, and you open the balloons, what do? They equalize, exactly. So that's exactly what a cascade solution is. You take a higher pressure from a lower pressure, and you make them equalize. So imagine your car's a lower pressure, the higher pressure is the system, we then fill. Car goes along, and eventually we just replenish that pressure, okay? Some of the customers, so Bonnet, we released a station in the Czech Republic about 4 weeks ago, and that was pretty popular on LinkedIn, so if anybody's live on LinkedIn, you will have seen that. That was our station, and we also work with companies such as Total and Arcola. Another exciting market is Australia and the APAC region, so working with Haringa and APCO. I touched on Haringa earlier with the hydrogen chase boat, but this system essentially allows us to modularize our approach to refueling. So what that means is we're going to have phase 1 of 8 stations, increase that then to 16, and then a further 16 as we go along. So pretty big ramp-up rate. So key considerations for refueling stations. If you walk away with anything today, please remember this, if this is something you wanted to do. Okay, so these are all the comments that we're getting asked. I'm going to focus on a few specifically. So let's have a look. Reduction in lead time to supply HRS. How are we focusing on that? Okay, standardization. You're only going to get reduction in lead time when you're buying more of the product. Okay, holding it in stock. Reduction in CapEx. Not interested in OpEx at the minute. I've got my funding, which is what we're hearing. We've got my funding at £10 million. That's what I've got to spend. Okay, great. Well, let's make it TCO compliant. These sort of things. So the feedback we're giving is, let's look at serving a 350 and 700 station. This is what we're doing internally over the last few years. We need a minimum of 2,000 kilos of storage on site. You know, we've got to be bold with standard solutions, so actually just giving standard solutions with very small engineered to order, ETO, and then offering configurators and a direct fill solution, okay? So I'm going to go into a bit more technicalities around refueling stations and the things to consider. So is anybody close with the protocols SAE J2601? Fantastic. I'm going to have fun today. Okay, so J2601 is the only fueling protocol that's out there at the moment for refueling stations. So if you're going to build a refueling station, it needs to be to SAE J2601. Again, key takeaway. I said earlier about some really important things to think about when you're making considerations for stations, and I'm going to tell you the difference, okay? So everybody comes to us in the first instance. Every customer, I say 80% of them, come to us and say, right, we need stations that can fill as fast as possible. 2 to 3 minutes for a car and 10 minutes for a bus. Okay, have you got £1.5 million? No. Okay, well that's again tongue-in-cheek, but there's some really important considerations around that. Under J2601, you've got the protocol that says T20 and T40, and it is literally as simple as temperature 20 and temperature 40, okay? Hydrogen combusts above 90 degrees. So we have a limitation of 90 degrees. So when we're building stations, what we need to make sure we're doing is that when we're dispensing the gas doesn't get anywhere near 90 degrees. So if I supply a T ambient, temperature ambient, so the environment that we're in, if I supply that in Arizona and it's 50 degrees, I've only got 40 degrees to play with, so my fill time is incredibly long, okay? If I supply a T ambient station to the North Pole, it would be minus 20, minus 30, you get a much quicker fill because you've got a bigger temperature delta, okay? So this is where T20 and T40 are important. So straight away, fast fill. I need it as fast as I possibly can. Okay, well you need to chill to minus 40. Can you actually swallow a 10 to 15 minute fill rather than a 2 to 3 minute fill in a vehicle? Well, yeah, I can actually. Well, you've reduced your CAPEX straight away by 50%. Okay, big impacts. So it's just really taken into consideration, especially when it comes to tenders and things like that. Okay, we need the fastest fill we can. We've got this much gas we need to get out, because hydrogen acts the opposite as every other gas does. Okay, of course it does. It's hydrogen, it likes to be difficult. So when we dispense hydrogen, it does the opposite Joule-Thomson, which means it gets incredibly hot. Okay, most gases, when you decant them, go cold and usually put frost on the cylinders. These get hot. Okay, so it's just considerations about T20 and T40. So standard stations is what we do. We created the standard stations, the Nano Pro. We've got a Nano currently in Slovenia, whilst the Nano Pro is in manufacture. So that's live, and then we're going to switch that over to the Nano Pro when that's finished in manufacture. Simple as this. One on the left is the equivalent EV charger. Okay, so it takes anywhere between 3 to 4 hours to fill. Very simple system. Takes gas at 500 and boosts up to 700, or decants to 350. Station on the right, 80 kilograms. Again, pretty quick fill, this one, fully electrical. It's got 4 compressors on there that allow you a fast fill within 10 to 15 minutes for a car, and can do a small fleet. If we then look at the bigger stations, so the Geno, these do anywhere up to 3,000 kilos. These are very fast filling, cools down to minus 40, and is suitable for heavy duty vehicles or light duty vehicles. So this is the Rolls Royce of refueling stations. Retails in the region of around 1.4 to 1.6 million, depending on the amount of storage that you need. And this is what's being installed currently all over the world through Haskel. So we're going to touch on the non-standard and bespoke solutions. So if there is a demand for a large amount of stations, we can build bespoke solutions. The bespoke solutions for us are perfect for customers like Heringa, who are influencing the buses they're supplying. So for example, 700 bar buses. Everyone's talking about it. Is it going to go 350? Is it 700? Lots of people are doing 700 now. It's starting to happen on the heavy duty vehicle side. So we're starting to design them. And the benefit of being part of Ingersoll Rand is we can source 70% of the products in a station within the group, okay? A big conglomerate, they go buy M&As all over the place to make sure we're securing that supply internally. So I touched on at the start the number. Can anyone remember the number? 10 to the 19, fantastic. Okay, so it's a big number, and why did I say that? It's because we've done some work internally over the last 10 years on the number of different configurations of station we've been asked to make, okay? And it's that number. And that might sound like a ridiculously big number, but it's absolutely true, okay? There's that many different variants of refueling stations. So no wonder this product currently isn't being rolled out internationally when there's 10 to the 19th configurations just for Haskel, okay? So all of our competitors will be seeing this. So we have a responsibility in this room, just as we do outside of this room, to make sure we're pushing standard items, okay? Making sure we're pushing legislation, making sure that codification is accurate and safe. You know, we have a responsibility to do that. So I hope I've managed to keep you enthralled. I'm trying to talk for the next 6 seconds, so I hit perfectly on 15 minutes, which I've just done, which I'm quite happy about. So if you've got any questions, please fire in this way.
Thank you, Jake. Thank you.